This is our first example from Unit 14 here. So let's just read the situation we have here. We've got a farmer who wants to create a rectangular animal pen. And he has 16 sections of fence, each of which is 1 meter long to use. What should the dimensions, and when they're asking for the dimensions, they're asking for the length and the width of the pen be to make the area as large as possible. So the key things to come out of reading this are, we want the shape to be a rectangle, and we want the area to be as big as possible. So let's just draw ourselves a little rectangle in here. Here's our length, and here's our width. Now, it tells us that we have 16 sections of fence that we can make that are going to go all the way around the outside of this rectangle. So that is telling us what the perimeter of our rectangle is going to be. Our perimeter, of course, is the distance around the outside, and it has to be 16. And that 16 is made up of a length plus a width plus a length plus a width. So length plus width plus length plus width. Okay. So if that has to add up to 16, what we want to do is we want to fill in this table down here with a number of possible different rectangles, okay, that satisfy these conditions. So this condition that they have to satisfy is they're all going to have the same perimeter. So over here in this perimeter category, I can just say 16, 16, 16, because I know the perimeter of each one of my rectangles has to be 16. For rectangle number 1, let's assume that our width is only 1 meter. Okay? What does our length have to be to give us a perimeter of 16? Well, let's see. If the width is 1, let's just draw another little diagram in here. If the width is 1, and the width is 1 over here, up here we have to make this 7 and 7, because 1 plus 7 gives us 8, plus 1 more gives us 9, plus another 7 gives us 16. So our length would have to be 7. If we make our width a little bit longer, and we make it 2, then we have to make our length a little bit shorter. Okay, we've got to shorten this up so that it's 6 up here and 6 up here, because 2 plus 6 gives us 8, and another 2 plus 6 gives us 8. So that would be 6. So do you start to see the trend that we're going to have here in our table? If we keep making our width longer, 3, 4, 5, 6, and 7, what's going to happen to our length each time? Yeah, it's going to decrease by 1 each time. So 5, 4, 3, 2, 1. That's the way it's going to work in this problem. Now, it's not going to be the same in all of the problems, but that's the trend that we see in this particular question. Now we want to figure out our area over here, because remember, we're looking for where the area is as large as possible. So how do we calculate our area if we have a rectangle? What's the formula? Yeah, area is length times width. So we want to take our length and our width and multiply them together. 1 times 7 gives us 7. 2 times 6 gives us 12. 3 times, let's see, what's our length here? 5 gives us 15. And I wrote down 16 instead of 6 there. Times 6. Okay. And we can work our way all the way down this table, filling in what our area is. 4 times 4 is 16. 5 times 3 is 15. 6 times 2 is 12. 7 times 1 is 7. Now, if we just look at what's happening to these numbers in the area column, what are they doing? How would you describe what's going on here? 7, 12, 15, 16, 15, 12, 7. If I were to just ask you in words what's going on here, what would you say, Drake? What are they doing here? Not the same amount every time, but what's happening as we go? It's rising, and then what happens down here? Yeah, it's going up, and then it's going down. Now, the next thing we want to do is we want to take the width and the area, and we want to make a graph. So I got a grid right here. I'm going to put width down here on the bottom, and I'm going to put area up on the side here. And I'm going to draw a graph of that data. So I've got 1, 7. I've got 2, 12. I've got 3, 15. 4, 16. And then I can just fill in the rest of them here. Okay? And I can draw a nice smooth curve between all of my points. Okay? Kind of like that. Now, what is that line doing? Well, it's doing exactly what Drake told us it was going to happen. It's going up, and then it's going back down again. Now, remember what we were asked for in the question. Where is the area as large as possible? Which one of these, if we look first at the table, what's the largest possible area we have in our table? The 16. So I'll just circle that in red. Okay? Where is that on our graph? Well, that's right here up at the peak. Okay? Area of 16. Area is on the vertical, so it's highest up at the top there. So for the rectangle with the maximum, the largest possible, or the optimum area, let's just make this a little bit bigger. What are the dimensions? The length and the width and the area. Well, let's see. Our area is 16. Our length and our width are 4 and 4. So we'll say L is 4 meters. Width is 4 meters. Area is 16 meters squared. Now, what kind of a shape is this if the length and the width are exactly the same? What kind of shape has the length and the width the same? It is a square. Okay? So if you want to make a rectangle that has the maximum possible area, you're going to make your dimensions, and you can change the length and the width. You're going to want to make your length and your width as close to the same as you can. You're going to want to make a square if you can. So here's a question where we have to apply this. Predict the dimensions and the maximum area of a rectangle with a perimeter of 60 meters. Well, we want to make a square with perimeter of 60 meters. So it's going to have, if we draw a little picture here of a square, we're going to have one side, one side, one side, and one side. And all those sides are going to be the same. How long does each one of these sides have to be to get them to add up to 60? How can I figure that out? How did you get that? 20, 40, 60 would only give you 3 sides, and we need 4. So what do we have to do with that 60? Sorry?
15.
How did you get the 15?
15 times 4.
Yeah, we take our 60, we divide it by 4, so each side has to be 15. Well, if each side is 15, what's the area of this thing going to be? How can we calculate that? 15, 15. Well, let's see. The area is, how do you calculate the area of a square here? And what is length times width going to be? What's our length and what's our width? Drake, what is our length and our width here? 15 and 15. So we just multiply those two together, and we would get 225 meters squared. And that would be our maximum area.